Tissue-engineered implants can provide a solution for challenging defects, enabling effective regeneration and restoration of damaged tissue and organ function, harnessing the regenerative potential of stem cell populations. Small skeletal stem cell aggregates can be differentiated into phenotypically stable microtissue structures named cartilaginous organoids. These can then be used as building blocks for engineering larger tissues bottom up. We enable this complex process to provide enough organoids for bioprinting of complex implants. We develop an automated platform combining robotics, bioreactor, and bioprinting technologies. During the process, we obtain real-time data on the biological progress, which allows us to make in-process decisions. Osteochondral implants are complex and will require the combination of multiple bioprinting technologies, such as extrusion bioprinting and laser-assisted bioprinting, to capture intricate tissue architectural features and provide necessary throughput. This integrated approach provides the unique opportunity to manufacture clinically relevant tissue-engineered implants in a robust, reproducible manner and cost-efficient manner, improving consistently patients' life in an affordable way.